Welcome to episode 307 of CppCast, the first podcast for C++ developers by C++ developers. I'm your host, Rob Irving, joined by my co-host, Jason Turner. Jason, how you doing today?
I'm all right, Rob. How are you doing?
Doing okay. Just a couple days after the long 4th of July weekend. How'd that go for you?
Oh, it's still going from my perspective.
Still going, fireworks still going off in the background or stuff like that?
Yeah, about 1 or 2 a night go off, which is exactly enough to now have my dog be afraid of dusk. So she'll just sit there and just start shaking at like 6 o'clock, and it's hard to get her to eat dinner and stuff, even if nothing is happening. And I'm like, okay, well, maybe my dog's just crazy, but I just happened to meet a neighbor who was walking past, and he said, yeah, the people behind him have been setting off fireworks every night for a week, and his dog refuses to go outside after 7 o'clock, no matter what's going on.
Poor puppy. That's sad. Yeah, I don't think we've been, I haven't noticed any in the evening the last few nights, but I think a lot of people, they're illegal to get like the really big ones in North Carolina.
They are here too, yeah.
But you can cross over the border into South Carolina and get really big ones. And I think a couple of my neighbors kind of went all out, and there was quite a lot going off on the 4th.
Yeah, for us, they drive up to Wyoming to get them. Same idea.
Yeah. Okay, well, at the top of every episode, I like to read a piece of feedback. This week, we got a tweet from Matt Price saying, when the pandemic started, I was caught up on CppCast. Then, without my commute, I got way behind. Now I'm only 3.5 months behind. Thanks to Jason and Rob for keeping up the good work. And yeah, we were happy to keep this going. We didn't want to miss out. There's no real excuse to be missing out over the past year and a half, whatever it was.
Yeah, and if you are just now getting back to commuting or something like that, then you probably do have a pretty good backlog to catch up on.
Yeah, definitely.
Because it's I think the average person probably has been working from home for 15 months now. Yeah, from our listening group.
Yeah, something like that. Okay, well, we'd love to hear your thoughts about the show. You can always reach out to us on Facebook, Twitter, or email us at feedback@cppcast.com. And don't forget to leave us a review on iTunes or subscribe on YouTube. Joining us today is Damien Buhl. Damien is the co-founder and CEO of tipi.build. He is an enthusiastic C++ developer, open source entrepreneur, CppCon speaker, game maker, community founder, Qt for Android contributor, Boost Fusion maintainer since 2014, and Yannic Staudt. Yannic is co-founder and COO of tipi.build. As embedded engineer and polyglot software developer, he developed many products from end to end and is currently busy building large parts of the front end of tipi.build, continuously perfecting his practice of coffee-driven business development. Welcome both of you to the show.
Hey, thank you very much. Hi, Robert.
Thanks for having us.
A coffee-driven development, that's kind of like test-driven development?
Yeah, I'm perfecting my coffee addiction. I need them to run, and I took it to quite a high level in terms of quality the last few years. So,
too high. We cannot have a good coffee machine at the office. It's never good enough, like for Yannic.
Well, that probably just got compounded by the fact that you've been working from home, right? Now you probably have your own espresso machine, and you tamp it down and hand grind it with like
I had that for a few years, but indeed last February I think I upgraded because the old one broke, and I went full out with the support of my wife, who I kind of co-addicted her in the last few years. And she tagged along, and this time she agreed to spend the right kind of money.
I'm almost afraid, but I still want to ask, what is the right kind of money for a good coffee maker?
Let's say you go, really good stuff starts at about $800, euros, whatever currency.
Right.
And in this case, counting the mill and accessories, etc., I think I run about at 3K, something like that.
So
it's a hobby. So
yes, it's definitely a hobby at that point. Yeah, I don't tolerate a lot of caffeine very well, but whenever I am traveling to Europe and they have one of the automated espresso machines where I can just press a button and it does all the things, I totally have 2 or 3 cups a day of whatever, right? But then I just learned from someone that some of those machines go to the point of playing a wave file of a grinder so that you think that it's fresh grinding the beans, and some of them actually fresh grind the beans.
Yeah, so that's the big vending machine. There are some that do fake it, mainly for cleanliness reasons, because the coffee oils are so they have kind of portioned stuff inside, and to give the good impression that you're getting something fresh. Indeed, they do play something. I know that quite in detail because I had the opportunity to work with such a vending machine maker a few years back, and so yes, it's a thing, but not on the kind of small desktop size home machines.
Right. Okay.
It even goes so far that he implemented in the tipi.build backend the HTCppCP protocol, that is an RFC from 1st April, which is like the hypertext coffee pot control protocol.
Yes,
so
exactly. So
if you get if you get to 418, I'm not a teapot. It's Yannic that was somewhere behind there.
Funny.
Okay. We have a couple news articles to discuss. Feel free to comment on any of these, Yannic and Damien, and we'll start talking more about tipi.build, okay?
Awesome.
Okay, so this first one, we have a post on John Heed-Manid's blog, and this is any encoding ever, ZTD text and Unicode for C++. And obviously, we've had John Heed-Manid on before a couple times, and he's been, talking about Unicode and text for a while now. I think it's been a bit of an obsession for him, and he, seems to have done what he's been seeking out to do with this post and with this library.
It looks like a lot of work.
Yeah. He's saying you can, encode, decode from one encoding to another, and even add support for, other encodings that maybe you care about that no one else would care about. So
that's pretty huge, actually, because until now there was only libicu, I would say, that was really capable of doing these kinds of stuff, if I'm not mistaken. And this was really missing to have such a library. I really like the fact that we finally have like a real iterator on smileys, because on emojis, because until now you couldn't iterate easily on emojis. It was hard.
Yeah, and I mean there's a lot of things that can go wrong in that time. I mean, junior steps, it's kind of like the first thing they learn is hard to master, like encoding, especially on system boundaries, like across protocols and network. There's so much to go wrong. So
yeah, and I sorry, go ahead, Damien.
I thought in the article he was really like pushing like that he is angry against not being able to do Unicode properly and so on, that he decided to show his middle finger or something like this. He said,
yes.
was a really energetic article. Like when you read it in the morning, you wake up.
It's like a good cup of coffee.
Yeah, exactly.
Indeed.
And it's funny because I was reading this and I'm like getting about halfway through, and I'm like, I know so many people who are concerned about the state of Unicode in the C++ standard. I'm surprised this article didn't come from someone that I knew, because I didn't actually look at the URL, right? And then I get halfway through it, and I'm like, I gave a presentation about this. I'm like, that's John Heed. Wait a minute. Oh, like I didn't even realize. It all makes sense now.
Yeah. Okay. Next, we have this post on blaycpp.com, and it's should every variable be const by default? And const is certainly important in the C++ language. I think it would be a huge change to go to const by default, but certainly an interesting article. I didn't realize, I don't think that that was actually the way that Rust did it, with having to declare a variable as mutable.
Mutt,
yeah.
I find it slightly annoying that it's mutt, but whatever.
You feel like it should be just mutable spelled out?
I think it should just be mutable, yeah. Okay. But whatever. That's a randomness.
But Jason, you are more like const export the things, right? No, not const all the thing. It's.
You're right. Const expert should be your default. If you can't do that, then const, and then if you can't do that, then fine. You're allowed to make a value mutable.
I find it really interesting. I also try to do that, to have const everywhere, but in some place where you do just copy, I think it's a bit overkill to like const everything when you just have copy arguments. But it made me remember to a talk at CppCon 2017, I think. There was a library named Immer, and the author implemented a notepad based on this library that he named EVIC. And this was about immutability and the fact that everything is immutable. You can make better parallel computation because you don't need to do locking when you change stuff. And you can even like do a flyweight pattern that works really well because you never remove anything from memory, so long as you just fill it up. But because you come back to states that already existed before, you are not like growing infinitely. And I found that really interesting back then, and I think it is somewhat related in the sense that you get better parallelism and so on. I don't know what you think about it.
Was that who was the speaker for that talk?
For Immer and EVIC, this was, if I'm not...
I have someone I can picture, but I can't remember their name. I was wondering if that's who it was.
If I find perhaps on the slides, Juanpe Bolivar.
Yeah. Okay, Juanpe. Okay, yeah.
Postmodern immutable data structures. Really cool talk, I think, and really great work there.
Yeah. Can I just make one nitpicky comment about this article, though?
Sure.
I'm sorry, but it bothered me because it happened twice. But they refer to const as a 4-letter word.
Yeah. I noticed that too. Yeah, I don't know why.
Off by 1 errors.
That's the hardest problem in computer science, right?
Right. Okay, and then the last thing we have is a blog post on Marco Arena's blog, and this is reversing words of a string with ranges. And you want to tell us a little more about this one, Jason?
Oh, I mostly just caught my eye because the hashtag that's a rotate. And it's interesting because it's transcended. It's not just that's a rotate. It's now I had an epiphany while programming. That's a rotate. That's
right.
Article here.
Shorthand for having an epiphany.
Yeah, that's a rotate. But I have to actually honestly admit that the actual implementation here is slightly lost on me. But reversing words in a string using ranges required a little bit of extra algorithm added here. But it's also just some educational bits about ranges. That like there's intentional design decisions about what kinds of iterators are resultant from different filters and stuff.
Yeah, I think one thing he said early on is this could be a lot easier if it wasn't because of some of those intentional design decisions. Like you could do it almost in one line of code.
Yeah. Split produces a forward range, but reverse requires at least a bidirectional range.
Right.
So that is why you can't just do split and then reverse the words after the split.
But does a view split is something that in the C++ standard now? Because I didn't try the ranges in the last compiler implementation by C+20. Mm-hmm. Is that something that you can do in a standard way, or is it only with the ranges v3 from Eric Niebler?
I am not nearly familiar enough to keep track of those differences. Now I'm kind of curious.
Because it will be what I liked in the article is to see the view split, because it was the first time in my life that I seen a string split in a one-liner in C++.
It did make it into the C++ 20 standard, and it is in the ranges header. So yes, you could do that in actually one line in real C++ code.
Wow, so cool.
That's good news, yeah.
because all this sregex iterator, tokenizer, and things like this was really like on multiple lines and so on. This having one liner for string split, that's really a good thing, I think. Because I've been waiting that for a while, and I've been looking with friends like during, perhaps weeks or months, we tried to have a one-liner in C++17 without any library, and we didn't get one that it was actually that you could actually recall or remember, or that was one statement. So that's really cool.
I mean, since white space doesn't really matter in C++, anything can be a one-liner, right?
Yeah, but I mean, one statement, that you can use, it returns directly. Like
I mean, and then there's maintainability, right?
Sure.
I love that all of these examples, I'm looking at the CVP references examples for split view. They actually are like const expr string views that they're splitting, which I like that, because, well, you get to reason more about what's happening in the code in that kind of case, in my opinion. But also the fact that ranges are, I think, fully const expr capable. So that's also handy.
That's nice. Okay, so Damien and Yannic, could we start off by just telling us a little bit about tipi.build and what it is, how it got started?
Yeah, sure. Thank you for asking. I mean, tipi.build is the home for native C and C++ developers. What we wanted to build is a tool that helps C++ developers and C developers to work like if everything was smooth, like if your environment was always ready, always installed, but you don't have to bother of downloading dependencies, and that you don't need to wait for compile times. And we actually seen by some of our first users in our beta that they spare a lot of time with what we are doing, like sometimes 2 hours per day. And it's actually, for us, it's a company that we started first as NXXM, and then we renamed it to Tipi because we incorporated the cloud component to it. And what you have to imagine, Tipi is like the extension of your machine in order to build C and C++.
So somewhere on the cloud is a running environment that is everything I need it to be.
Yeah.
It's a part of it, yes.
Okay.
So you can select your toolchain. You say, I would like to build for, I'm a macOS and I would like to build for a Linux machine. And many developers do that. They have like a remote Linux server, or they have like a VNC or so, or something like this on the server. Mm-hmm. But it doesn't feel like natural because you have to drop in a remote window. There is lag on the network and so. So what we wanted to bring is an environment that you can run, and that brings you directly to build directly your C++ code without any hurdle, so that it's a seamless experience, a refreshing experience for C and C++. So you can simply, like, say you are in your editor and you code some lines, and Tipi is going to synchronize your files to the given environment, and it's going to build it there, and it's going to bring you back the builds. So you can like build in parallel for 10 platforms, like saying I build for Linux, for Windows, for Mac in parallel, and I get all the binaries back that I can then release to others. It's also working in an asynchronous way. That means you are not remote on an SSH connection, or in a browser window, or in a remote window where you are like waiting on the server to reply if your connection is not working, if you're commuting, and so. It's directly something that you edit on your computer, you have the file on your computer, but it helps you in adding more RAM and more CPUs to your computer so that you can build in an easier way, in a faster way, actually. And inside Tipi, to remove all the barrier to C++ adoption, actually, we have a dependency manager that is smart, and then that is based on a smart algorithm that can automatically build any project based on code scanning. And naturally, we don't force that. We are not obliged to use that. But most of the time, people, when they start to use our solution, they switch to the algorithm completely because they just see it works, and it's just less work. And it doesn't prevent you to like configure stuff. We are not opinionated of saying like in this particular case you want to do something special, you can still add hooks and so on. But the idea is to make C++ as easy as it is to write code in Go or to write code in Rust or so on. It's like really having a seamless experience, because one of the biggest problems is having your environment ready, actually. And this is what we are doing at TP with tipi.build. Yeah. And perhaps Yannic would like to add a note on the continuous integration support that we're working on.
Yes, we're currently we are adding support for GitHub Actions. So kind of wiring up into that to have faster and somewhat cheaper runners. We are looking to do the same for GitLab and for Bitbucket at this point. So kind of to keep the same level of comfort, so you still write whatever is native to the source and so to the version management you're using. So you still can just keep your GitHub Actions YAML and so the workflows, etc. And we kind of try to make it as seamless as possible to just drop in there and bring all the performance and comfort to that. And what Damien actually kind of didn't mention is you can remove the CMake list files from your solution mostly, and we build them. The algorithm builds them for you.
And perhaps one thing is that we noticed is the CI services that you find online. They are priced and sized for web development. When you take a GitHub Action Runner, or if you take GitLab CI/CD, or you pay the minute really in a really costly way, because it's thought for web workflow, but are not going to build long. So the services, they need to have something back for spinning up nodes and building the stuff. So they price the minute in a really costly way. And added to that, the nodes are pretty small. Like a standard nodes typically are like 14 gigabytes of space. And if you are a C developer and you make a debug build of some big C++ code base, or if you have like a Linux environment that you're building like for an IoT device, then it's not enough. And then the solution is host your own runner and so on, and do a lot of work, while we can just say runs on label tp.build.macOS, and then you get a macOS runner for your build that is priced at a job basis. The idea is like you don't need to pay by the minutes for the CI build. You pay like for the parallel jobs, and I think it's really a problem that C and C++ has in terms of build size. I don't know about your experience, Rob and Jason, with build sizes and so on build times, but
yeah, I mean, I could go look right now, but I just had to delete a bunch of code from one of my VMs so that I could make my next build that I needed to make. So there's that. Although, to be fair, my binaries had really exploded because I was doing debug builds with UBSAN and address sanitizer enabled, because I was trying to track down something that I could not reproduce on my local machine. So it made very large builds in that case. But to that point, like you said, you can just kind of remove your CMake list in many cases because your algorithm's smart enough to pick that up. But some of the projects that I'm working on, they are building Ruby modules with shared libraries, and because of platform limitations, in some cases, we have to do like a static link of the libraries for one thing and a dynamic link of the libraries for another thing, and then we have to, find the system Ruby and link against the system Ruby standard SO, that kind of thing. Like, is that still supported in your environment?
As said, we are not opinionated on the fact that you can still have in some branches of your project, you can still have a CMake list, for example, that will, for one folder, decide things. You can also have like declarative configuration, because the problem with CMake is that it's imperative, right? And so it's really likely that you generate CMake lists that are difficult to maintain and that needs to be debugged, that you will need to rebuild often,
right.
so that you know what you're doing. And we have like a declarative configuration, in the sense we just have a JSON where you specify that we autofill, like with what we discover for libraries that you are using. We fill it with the library we found on GitHub, on GitLab, and so on. And you can then pin versions, or say, okay, but I want this special preprocessor argument, or I want this special configuration, this special function for this platform to be selected. However, if you still need to write like actual CMake list in your code, you can say, okay, I benefit from the TP algorithm for most of my code base, but in the part that is specific to the platform specific part, then I will just write a CMake list there and make a small file, a hidden file that tells to TP that he needs to read the CMake list there and add it in his own process. And there you can do some fine tuning and so on. But the reason why we went for such an algorithm is, if you want to depend on some libraries today, you have to be in the same build system than the library vendor or the library author, and you need it to be properly written. Like writing a proper CMake is, for a library, just like a simple header-only library, writing a proper CMake so that you can find packages and so on. It's mostly like 120 lines of code. But most of the time is hard to get right. And so for this, we had like different stage of the algorithm. The first thing is, if you respect conventions like the pitchfork layout and so on, conventions, then we just build that based on the conventions. If the convention doesn't work, because for example you are building for multiple platforms, like you have in your code base, some CPP file for Win32 and some CPP file for Linux, then we know for which toolchain you are building, because you specify that when you say tipi.build for Windows Visual Studio 2019, for example. Then we are gonna check, is the headers that are included in this file, are the symbols used in this file something that is part of the platform? Mm-hmm. And if it is the case, then we can take it in the build. If we see it's including macOS specifics files and symbols, then we are not going to build it in this process. And the last thing is, when you have like a configuration error, this is like the really hard part. Like you have a build system that is generating a configuration error, or generating files, and as you said, like for Ruby and so. What is going to happen is, we have a cloud, so we can spin a lot of VMs. You can also do it locally, but you might need a bigger PC. And we are going to try many combinations and find out which one works. And because we also detect unit tests, then we are going to run the unit test and see if the unit test passes, and if there is one where it passes better. And then at the end, we are going to provide the special detection to the user, so that he can say, yes, this fits me, and he has then the stuff built. And this is we have been working on this since a long time. I've tried in 2017 already by putting everything in a single header, and that's why we come then to the other part of the algorithm that bring build speed. And actually, it's the same idea. It's like if you were bringing everything in a single header, but we split it across files, and we make it so that you can compile it. It's the trick that we use use behind.
To back up from like the CI/CD and build configuration stuff you were just talking about, you said you can run this locally, and then you won't have to set up a compiler or anything like that. So if it's a fresh environment, I guess you can just get going with Tipi. What does that look like? What do you have to set up to connect to your Tipi service?
The first thing is you download the TP binary. Like it's a one-layer to drop in a command line, or you install a Visual Studio Code extension. We are working on other extension like Visual Studio as well, but this is not yet done. And then at the first start, we are going to download the the default environment for your machine. We have a Clang for Linux. We have a Clang for Windows with libc++, and a Clang for macOS with libc++ as well. Like having always the same basic compiler. If you have compiler on your machine, we can use them. But you can also say, I want to use, for example, Visual Studio. And then we are going to, because if we don't find it in your local environment, and because we cannot ship it, we will then spin a VM where it's in there. And TP is going to synchronize the files of your current folder in a tipi.build node. And it's going to build on this Windows machine remotely and deliver you the binaries back. And actually what our toolchain files are, it's a CMake toolchain file, like specifying all the specific IAs of which options you want, which optimization flags you want, and so on, plus a Packer image. That means it's always a pair of a toolchain file and a VM. But the VM is only the system, the base system, base compiler, basic tools. You can add urons on top so that you have your typical tool that comes with. And then TP is going to build that either automagically by using our algorithm, or if you really don't want, you just say, no, use my CMake list. But then if you do that, and you do it for your full project, then you lose a bit of our advantage, is that we can split the compilation. We can parallelize it at a finer granularity, actually. We will spin up nodes based on what you have in your subscription. Like typical, if you take a TP Pro subscription, then you have like 128 cores included. And what happens is when you build, we look at the files and we split them if we see, okay, there is a template instantiation there and another one there, and there are two functions that can be compiled separately. We are going to split them in separate files.
Wow.
And if this doesn't make sense because we measured that preprocessing will be higher on each separate file and that you will lose time on the linking part after, we won't split it. But in most of the case, we will be able to split things. And so we will not just build after each translation unit, but we will parallelize after each function that you have in your program and link them incrementally during the process there. And so that's why algorithm is also a key part. Is if you do full CMake, you get the advantage of having the environment, the build cache, and having everything remote. But if you do use for some of your folder no CMake, like when you have just the plain algorithm and so on of your application, then we can actually generate the CMake list for you, and we can split the build process in a way finer granular way. And because we do that through files, we can drive any compiler. It's not like you need your compiler. It's just a pre-processing step before that makes it possible. And because you have the cloud, we build continuously. So you edit and it builds and you get back the binaries. And in the future, we might add hot reloading and stuff like this. So it's really about bringing seamless experience to C++ developers.
So I never, if I understand what you're saying, I don't ever say like type make on my system if I'm using TP. It's just building whenever I save a file.
Per default, yeah. If you don't want this,
okay,
you can naturally disable it and just say TP build yourself on the command line or through a button in the IDE. So it's a choice. Per default, we offer that, so automatic. We first synchronize and then build, and again synchronize every time. But we understand that not everyone wants this, so it's also possible to just manually do it. And everything that we offer is command line possible. So it's possible in command line, so you don't need to, you're not tied to some environment, and so you can integrate it anywhere. And we are going to open source it, but at the moment we are actually in a phase where we battle test it with different users, and that's why if people join on a website, then they get a seat, and if they fill in the Overtaker questionnaire, we bring them up in the list, and based on their use case, we get them in our beta, and in end of the summer, we will at beginning of September, October, we will bring an open source release of it and a public release of the solution.
It sounds like you're actively looking for beta users to join and try out Tipi right now.
Yeah,
right?
definitely.
Yeah, if someone has an interesting edge case or something at scale or something that they'd really love to try, give it a shot. It's interesting for everyone, I think.
And the point is, we are so if you take a seat early because we are a startup, so we cannot like open our cloud suddenly to everyone because we will have scalability issues. That's why we need that. And for the moment, we do deployment on a user basis. Like every user gets his own deployment, and we are working on the automatic onboarding, so that we can deliver some features to the different users in a more automatic way. I mean, in the end, it will be open to everyone, but it's just like we cannot like open to all 5 million C and C++ developer in the world, and they can then build on a platform. Otherwise, it would just explode on our cloud. Your cloud will just not follow. So we are working on that at the moment, and scalability issue, like
yeah. And what we didn't say is basically we during the time you're not building, you can reuse the resources you basically bought to have access to a remote machine. So basically, we have a tipi.build and we have a tipi.run part of it. So you can reuse the nodes. Basically, you build your application, you're sitting in front of your Mac desktop, you want to compile the Linux binary, and then you can't execute it, right? And so we basically give you the option to use the node to execute the Linux binary in the same environment. And we redirect I/O. We're even trying at this point to have some VNC facilities, so for UI applications to transport the rendering across the network. That's a very, very early pre-alpha. So, but things going on in that direction too.
Yeah, I'm curious about that in the continuous build model. Like, how do warnings and errors get reported back to me from my code? And I'm particularly curious, since you said you can take one file and split it across multiple compiler instances. How do I get back the warning to know on line 12? That's where my code had a warning.
When you do the preprocessing of a C++ file, when you run like GCC with -e or -p, -e is like uppercase E. You get like marker in the file, like that this what was preprocessed expanded the code, but the compiler will return a warning or an error at this position or this other position. So we abuse this mechanism so that the compiler, when you get a warning and error on this splitted file, that you get the warning at the right place. It's like a bit like source maps. And the point is as well, I mean, we try also to keep lines and things like this. When we do modification in the file, we try to add them on a single line, not to inject lines and stuff, and so that you get an error at the right place. Yeah, this is an important thing. And we have like during live compilation, we have like FTX UI from it's a library that was featured recently. It's one of our users actually, as we are named in XXM, and we are using the FTX UI library to actually provide you the different platforms. At the same time, you have the log of for example, if you build for the free platforms, macOS, Linux, and Windows in parallel, then you get them in different tabs of your console. or naturally you can still output it to separate terminals or to files, but you can get them like live and see, oh, it's compiling on Windows, it's green. Oh, it doesn't build on Mac. Oh, it builds on Linux. So you can then focus on what you want to fix, and every change you see directly if you're breaking this platform or this other platform without waiting for the Cotus integration to run.
Wow.
This is because this is the use case we had. I've been working in a cross-platform development in like IoT and so for 10 years before, and I always had this problem. Like I was building for one platform and then I break the 10 others, and I wanted to have this feedback directly. And this is one of the solutions we brought there.
It's actually for Tipi, for the application itself, it's super useful. So we heavily dog food the thing. So we make heavy use of that feature.
And before you spoke about Asan and Ubisan and so on.
Yeah.
And what I always had as a problem when I was working in teams and so coming to new teams, I noticed that all this stuff weren't set up because you need to add them in your CMake list, you need to make some setup, you need to have them and so on. And this is also something that we have in Tipi, is that we enable all this stuff per default, and we get them run in a nightly. So you get information, what you did today, we found this and this error, and this is just for us another cloud instance to run in parallel so that it doesn't disturb your actual build. Mm-hmm. It's actually what we would love is that people feel like C++ is as easy to write as writing JavaScript, like to just drop some lines and it works.
So on that note, then you said you enable ASAN, UBSAN, whatever in the nightly builds. Does your build environment also support things like CppCheck and Clang Tidy? And how do I adjust the warning levels if I'm using your AutoMagic feature?
As I said, you can still we integrate well with CMake in the sense CMake is your internal tool. It's just that CMake is something that is not meant to be given in the end of the developers, in my opinion. It's like Make, it's something you don't want to write yourself. You want to be able to tweak things, but you don't want to be the one that writes that. And what we offer is like opts file. On this opts file, you can add some CMake specific ID inside it.
Okay.
And but we try to restrict it to declarative things. Regarding the Clang Tidy on Ubisan and Asan, so these can be directly provided in our configuration in JSON, because these are like generic settings that are declarative. Is not something that you need to do a if else in CMake or something like this.
Right.
That's the point. Yeah.
Okay.
And
well, yeah, I mean, you've mentioned a bunch of different platforms, but if you could just kind of lay it out for us, what platforms directly do you support?
At the moment, we officially support Windows with a special Clang with libc++. So C++ 17 and so on. 20 is coming. On the Linux and on Mac with this compiler, and then we have Visual Studio for Windows x86 and so, and we have like a GCC for some cross compilation for Linux IoT devices and so. But we have a gigantic list with iOS, Android, and so we have customers that are using iOS and Android in their build. And they can do it in the sense they can write their own image, like saying, okay, this is my declaration of what the VM should look like. This in this Packer format, and then they add the toolchain file to it. And as we grow, we are going to have even more of them, and having also test nodes that actually works for this. We are looking for possibilities to run tests not only in a iPhone simulator, for example, but running it in a real iPhone and things like this. We are like looking at things like this at the moment with some users, and that's actually the thing that is key behind Tipi is this pair of toolchain files and toolchain names on the VM image behind. Yeah. And you can actually, you don't need a cloud to run it. You can actually deploy it locally in your machine. It's like building on a Docker, for example, but we choose the extra another level of indirection, like in the fundamental theorem of software engineering, because then you can do VMs from any kind, macOS as well, and you can also do Dockers. We just don't default by Docker. That's the key. On our cloud, we don't build in a Docker in Docker container directly. We respin a VM for security reason. Because we don't want someone to be able to steal the code of someone else or access.
Right.
Because if
the isolation is just not good enough.
Yeah.
So for our listeners who want to just go try this out, do you have like a free tier or a trial tier or something like that they can test with?
Actually, at the moment, it's still a closed beta, so they have to join.
Okay.
They get on the waiting list, but we empty it. We bring the people up every month in the waiting list, and people get it. The point is, the version that you have is a free version. You can use it locally, and then you can add stuff that gets with the cloud, and we are going to give like for free some build minutes and so that you can try. And this free version is really going to be open source at the V1 release. We just didn't do it yet because it's a lot of work to open source everything. It's a lot to have like to check out that everything is clean, that we brought the repositories in the right folder, on that we can react to issues and pull requests. This is also something because we are still hiring at the moment and so that's the reason why it's not yet open source, but it will be, and that's why the beta users, they get access to it earlier than the others. That's definitely one thing.
Do you have any idea when you're going to hit that V1 release date, or when you are going to plan to open source it?
It's happening this year.
Okay.
The goal is
there's only half of it left, so that's what we go by at this point.
Now go ahead, Damien.
Yeah, sorry, I didn't know if I like saw Yannic frozen. That's why I'm. But if you hear his message, it's okay. We are releasing this year at the latest in Q4, and otherwise this summer. Yeah.
Now the parts that you say that you're planning to open source, does that include this fancy build algorithm that you were talking about that can split up our files and make them even that much more parallel?
Yeah, because I think there is a lot that the community can bring there. And for example, what our algorithm does is that it follows the information that you get when you build with the file normally. You get information. Preprocessing took so much time. Instantiating the template took so much time, and so on. And we use this in our calculation to define what we split, what we don't split, and so. And I think open sourcing this is definitely something that makes sense because it's gonna being improved, and it's something better for the C++ community in general. So it's just that it's a lot of work based on the LLVM clone parser and so on, and we couldn't open source it that easily yet, so that's it.
Right.
Gotcha.
Cool.
Yeah, very cool. Well, you mentioned you're looking for beta users. Is there anything else you want to tell us about before we let you go today?
If anyone wants to try like just the CI or to have it, or they have like a special platform, like a special hosting. For example, we had someone approach us with Bitbucket that we didn't have yet. So we are working on this now. If the people have like special needs, just join or drop us a mail, call us, or write in the overtaker questionnaire what's really needed. We will just bring them then a trial version that they can try and enjoy it then.
Okay, very cool. And what's the website where everyone should go?
Sorry?
What's the website where listeners should go to check everything out?
So,
tipi.build.
tipi.build. Okay.
Yes.
Which you have
TIPI.
underneath your name right now.
That's
Yeah,
exactly.
actually-
Underneath mine, it is written.
Yes. So if you're watching the video, it's been here the entire time.
Yes.
Okay. Well, Yannic and Damien, thanks so much for coming on the show today.
Thanks for having
Thank
us.
you very much, Rob. Thank you very much, Jason.
Thank
It's
you.
really nice to be there, to speak here. I really like how you maintain this flow of podcast every week. That's really awesome. You're a really great team, right?
Thank you.
And yeah, let's see if we can help you further in the future.
Okay, great.
Yes, yes, you can do that, but you certainly can have that output. As you are running your cache2 test, you can basically take that output and then pass it to the Tuka server. So in this case, you are integrating the Tuka client library with your unit test, executable. So that's possible. And I think I like that approach more than having your output stored in a file and then later have a separate kind of process for submitting that output.
Right. And can Tuka tell you that, some numbers trending down or trending up or staying flat? Okay.
Yes. So I guess at this point, the analytics that we provide for the behavioral differences is slightly more mature and more helpful than for the performance. However, Tuka can show in its UI the trends of differences for different functions over different versions of the code. And I have found it very helpful because usually, you want to look at a chart and see that over time, your tiny little code changes kind of amount to a performance hiccup or a slowdown in a piece of workflow. So all it does right now, the interface is just giving you a chart, showing you how the performance changes over different versions.
For many things, that's good enough. Yeah.
Yes, I think that might be enough for people to find value, but I have much higher ambitions in terms of how to make it more helpful for users. In this case, I really think that tracking performance is slightly more tricky than behavior because it usually has some noise.
Right.
It is not guaranteed to stay exactly the same. So you want to have a way of looking at the performance changes as a human being looks at it, right? We look at a chart, we say, oh, well, this dropped 1% or 2% for this particular version, but we don't care as long as this is not consistent over a few versions.
Right.
Should we talk more about like the actual Tuka website interface and what that process is like? I did watch one of the videos you put up that was linked to that article 2 weeks ago.
Awesome. Yes. So again, I think the Tuka server helps you not just store your results, but also compares them against different versions. Now, the comparison certainly has some output in the differences. So the server attempts to visualize those differences. And the visualization of those differences is something you can look at for each given version. As your test is being executed, you can go have a look. But then after all the test cases are executed, the server is going to send a notification to members of your team and say, hey, this particular version that you just ran has these differences. So that report that it generates is more high level because it's meant to be consumed by everyone to give them an insight into how this particular version has behaved. So that you can look at that email or Slack notification and say, well, this is not what we expected, so let's go take a look. But in some cases, you may make intentional changes to the software, in which case you would use the platform again. You go there, you click a button and say, "This from now on, this is the version that I trust, that my software should behave from now on." So that is also kind of automated, the way that all these versions are basically tracked. You can add comments to kind of communicate with your team members, and then have audit logs for how your software is evolving over time.
Now, do I need to inform the Tuka server that I'm going to add some new variable or value, or can I just do that ad hoc? Okay.
You can do that ad hoc, yeah. In fact, you can do that with test cases as well. You can add, as many test cases as you want at any one time. the advantage of having this remote test server is that it is aware of the test cases that are part of your baseline version, right? So the advantage for that is you can then not have your test cases listed as you're running the test. So a normal Tuka test code doesn't specify its test cases, because when you have access to the library can query the list of test cases from the server. And therefore, you don't have expected values and you don't have the list of test cases. All you have in that regression test code is how you run your workflow under test, and then what data you want to capture.
Okay. I don't think we've mentioned yet what platforms, compilers are supported.
Yes. So the C++ client library for Tuka has support for all platforms. So all known commonly used platforms, right?
Windows,
Linux, and
so I can work on my Commodore 64 code that I've been. No,
I am regretting to say having said that, but in general, I think because the end users might be using code bases that are somewhat dated, I wanted to support a wide range of compiler versions, a wide range of standards. So starting C++11, it kind of covers the relatively recent versions of the C++ standard. And then the compilers, I think GCC 8 and Clang 8 are both supported, as well as MSVC. I think for 2013 is supported. Wow. Which is giving me a lot of headache, to be honest.
Yeah,
so you might drop it.
No.
Yes, you might drop it going forward.
Yeah, that's
right. Yeah.
I think 2015 would even cover most of the current console dev kits, actually.
That's right. However, because this started as a side project and then kind of obtained as an internal tool at my former employer, I had to make it possible for us to use it with the most outdated codes that we had, which happened to be using MSVC 13. So.
Okay, so I feel like I should ask this, or I'm very curious. Anyhow, you mentioned in your bio that you recently left your former employer to pursue this, and then you've also just publicly said that you began development of this project at your former employer. So you left with their blessing, I assume, to...
Yes. So for our listeners, So at least in the US, I think the norm is that when you start working somewhere, your future IP, developed IP, would belong to the company that you are working for.
Right.
And that seems a little weird for others, but here we all understand that. Now, the problem was, because this was started when I was working at my employer, so I basically had to work on it only at nights and weekends. But then, because I was so obsessed with it and everybody knew that I'm working on it for so long, they all had my, kind of their blessing. So I got the IP rights, and that's only when I was able to start speaking with people and showing the product to them outside the company.
Oh, and the way you had described it, I thought that you had actually started development on this on the company's dollar, which they would own it, I think, in pretty much any country if that had been the case.
That's right. Yes. Yes. But this was a side project. And for me, it was very important to kind of separate the work that I am doing for this project with all the other work that I do for the company,
right,
tasks.
Okay.
So that's cool.
Yeah.
You said you've been working on this, I think, for 2 or 3 months, kind of on your own.
Full time. That's right.
How well has that been going? Like, are you getting funding? Do you have users?
No, I don't have funding yet, and I'm not seeking funding right now. I'm seeking my first 10 customers, 10 paying customers, I should say.
Mm-hmm.
I have since leaving Vital, I have now about 10 active individual users that are using the product on a weekly basis. Now, there are also a couple engineering teams that are evaluating the product for larger scale use in their organizations. Now, I still don't have any paying customer, and I'm actively working on finding my first 10. I want to say right now that my primary objective is to get as much feedback as I can from actual people who have this problem, the problem that we had at my company. So the conversations I've had with software engineers over the past 3-4 months has been extremely interesting. Just to find that we all are suffering from the same issues is kind of giving me goosebumps. But in general, it's also very motivating in terms of the possibilities of improving what can be improved in terms of how we maintain software at large scale.
Right. Well, so if listeners are interested in trying out the project and becoming a user, paying or otherwise, what kind of options are there?
So right now, the platform, so I should say that the remote Tuka server can be deployed on-premise as well as a cloud-hosted version. So the cloud-hosted version is deployed at tuka.io. Listeners and anyone who is interested can actually go create an account for free. They can use the client libraries for C++ and Python to submit test results. So everything is free right now. But once they want to use it for teams of up to, say, more than 5 members, then right now there is a pricing plan, but it's still I don't want it to be a blocker. I want to kind of just have users that are using the product and not worry about paying. So in general, everything right now is as free as it can be. And I'm going to keep the free plan for the tuka.io platform, forever, permanent. So there's always a way of, working and getting value out of this product without paying anything.
Okay.
Very cool.
So like I mentioned before, the project I'm working on already has a regression solution that does work. So I don't know if we would be interested for this particular, for that problem with your solution. But I am really needing to start tracking more statistics, like binary size, bloaty output, ABI diffs, that kind of thing. Can I use the Python interface to push those things in a meaningful way to?
Yes.
Okay.
So I think it was 2 weeks ago when you mentioned that on a podcast. And it's interesting that it was the first time that I was thinking of this, being a possible use case. And therefore, I was interested enough to try it with the new client library for Python. So I'm calling the ABI diff and then getting the output and submitting it to the platform. It's very simple. So by the time that this podcast is released, I'm hopeful that I can have a GitHub repository that is public that shows how to do this, so that anyone who is interested can try.
Awesome.
Very cool. Okay, well, where should listeners go if they want to go and try out Tuka, Pejman?
I would recommend that they start with tuka.io. There are links there, especially in the documentation, to GitHub repository for the C++ client library if they want to start integrating that and then getting started. And there are so many different getting started guides in terms of, just if they are curious to get more information about how the platform works.
Okay. Anything else you wanted to tell listeners about before we let you go, Pejman?
Well, I just wanted to mention that this project started with a C++ client library, so it's near and dear to my heart in a way. And I feel like the best that I can get out of the C++ community is their advice and feedback. So I'd like for your listeners to see if, check out the product and then see if they can find it useful or not, and then share their thoughts with me as I'm starting this journey. Another thing I wanted to mention is for the past 3-4 years that I've been listening to this podcast, I've been thinking that I would come, if I would ever join you, I would plug the work that you're doing at my former employer now, which is certainly interesting, technically very challenging, and for a C++ engineer, it's the best type of work that I've ever experienced. So I'm sure that we're still hiring. And if you're interested, looking for a fun challenge, check out Vital Images.
Vital
I don't
Images.
think we've ever talked about medical imaging on the show before, but I'm sure there's a lot of C++.
I turned down a job that was related to medical imaging because it made me too nervous. What if I got something wrong? I didn't want to kill someone, basically.
Yes, but on the flip side, writing good code might actually save someone's life.
Yes, that's what my wife tells me, but yeah.
Okay, thank you so much.
Thank you again. Yeah.
Awesome. Thanks for coming on.